Good morning to all. This is T. Aftab Hussain from second year mechanical, studying in SRIT college. Subject name is thermodynamics. In thermodynamics, here the topic is about discuss the PVT surface and the significance of TS and HS diagrams. Introduction to PVT surface. The PVT surface represents the relationship between pressure, volume, and temperature of a substance. These three-dimensional surface helps visualize the states of matter and phase changes in thermodynamics. Understanding the PVT surface is crucial for analyzing the behavior of fluids in various engineering applications. And here is the graph, here is the diagram which shows pressure, volume, and critical point, and which solid state and liquid state, and where the solid vapor and triple line, liquid vapor and vapor gas. Components of the PVT surface. The PVT surface is constructed from experimental data for a given substance, illustrating its thermodynamic properties. Each point on the surface corresponds to a specific state defined by unique values of pressure, volume, and temperature. The surface can show areas of phase stability, phase transitions, and critical points for the substance. Phases of matter on the pressure, volume, and temperature surface. The pressure, volume, and temperature surface distinctly shows solid, liquid, and gas phases, as well as phase transition lines. Phase boundaries are critical points where a substance can change its state, such as from liquid to gas. Understanding these phases is essential for processes like condensation, evaporation, and sublimation. This is the most important processes which are used in evaporation, condensation, evaporation, and sublimation. Here we can see the pictures of solid, liquid, and gas. Solid, it is a rigid and fixed shape, fixed volume. It has high density. It has a closely tight and organized particles and slightly compressible. Liquid, not rigid, no fixed shape, have fixed volume, average to high density and closely tight but not deorganized particles and slightly compressible. Gas, not rigid, no fixed shape, no fixed volume, low density. Introduction to temperature and entropy diagram. TS diagram is temperature, T means temperature, and S means entropy. The TS diagram The TS diagram is a graphical representation that illustrates the relationship between temperature and entropy in a thermodynamic system. This diagram helps analyze heat transfer and efficiency in thermal systems, particularly in power generation cycles. The areas under the curve is a TS diagram correspond to energy transfer, making it a key tool for engineers. Here we can show the diagram, TS diagram, temperature and entropy, where it is compressed liquid and convert into adiabatic reversible and adiabatic irreversible. And critical point at the mid point in one you can see that liquid vapor mixture. In 3 you can see the superheated vapor. It is P1 and P2. Significance of TS diagrams. TS diagrams provide insight into the performance of heat engines and refrigeration cycles. They help identify optimal operating conditions for maximum efficiency and minimizing losses. Engineers use TS diagram to design systems that maximize work output and minimize energy input. మనం ఎగ్జాంపుల్ మనకు ఫ్రిడ్జ్ చూసుకోవచ్చు, ఇళ్ళల్లో ఉంటుంది. మనం అంటే మనం పైన పార్ట్ని బాగా కూల్గా ఉంటాయి, పైన మనం డీ ఫ్రిడ్జ్లో పెట్టేటివి. మామూలు నార్మల్ ఉంటాయి. అదే మనం కూరగాయలు ఏదన్నా పైన పెడితే అవి మళ్ళీ గడ్డ కడతాయి, అప్పుడు మనం తినలేం కాబట్టి అందుకే నార్మల్లో ఉంటాయి అన్నమాట. Introduction to HS diagram. HS diagram means enthalpy and entropy. H means enthalpy, S means entropy. The HS diagram is another important graphical representation in thermodynamics. This diagram illustrates the relationship between specific enthalpy and specific entropy for a substance. The HS diagram is particularly useful in analyzing processes involving phase changes such as in refrigeration and steam cycles. మనకి మాలిక్యులర్ డయాగ్రామ్ ఉంటుంది, స్టీమ్ టేబుల్స్లో చూసుకోవచ్చు మనం. హెచ్ఎఫ్ హెచ్జి అండ్ ఎస్ఎఫ్ హెచ్జి ఇవన్నీ దాంట్లోనే మనకు వాల్యూస్ ఇచ్చింటారు. మనకి ఏదైనా ప్రాబ్లం వస్తే డైరెక్ట్ ఆ వాల్యూస్ తీసుకొని డ్రైనేజ్ ఫ్యాక్షన్ అండ్ ఎంథాల్పీ అండ్ ఎంట్రోపీ అనేది కనుక్కోవచ్చు. ఎంట్రోపీని మనం కిలోజౌల్స్ ఇంటూ కేజీ ఇంటూ కెల్విన్ తీసుకుంటాం యూనిట్స్. ఎంథాల్పీ కిలోజౌల్ పర్ కేజీ. Importance of HS diagrams. HS diagrams facilitate the calculation of work and heat exchanges in thermodynamic processes. They provide a clear visualization of the energy transformations occurring in a system. Engineers rely on HS diagrams to optimize the design of heat exchangers and other thermal devices. Thermodynamic processes. In thermodynamics processes, you can see that isothermal means it is a temperature process which show the straight line, and adiabatic which shows the curve. Isochronic, it is shown that straight line, and isobaric it is also straight line. In PV diagram, this is all PV diagrams. Key features of TS diagrams. TS diagrams illustrate isothermal and adiabatic processes, allowing for easy identification of process paths. The area under a curve in a TS diagram represents heat transfer, making it vital for energy analysis. By examining these diagrams, one can identify irreversible processes and their impacts on system performance. Key features of HS diagrams. HS diagrams clearly show the enthalpy change associated with phase changes and thermal processes. The slope of the lines in these diagrams represents heat capacities, aiding in thermodynamic calculations. By understanding these features, one can make informed decisions regarding energy efficiency and system design. Comparing TS and HS diagrams. While both diagrams represent state properties, TS focuses on temperature and entropy, and HS implies enthalpy. Each diagram serves specific analytical purposes. TS is often used for heat transfer, while HS is used for energy calculations. Understanding the relationship between these diagrams enhances the overall analysis of thermodynamic cycles. And here is the diagram. Here is the temperature and available energy and critical point where the A to B and B to C and C to D and E to F. Applications of PVT and TS and HS diagrams. These diagrams are widely used in industries such as power generation, refrigeration, and chemical processing. They are essential for engineers to design efficient systems that meet energy demands while minimizing waste. The use of these diagrams aids in troubleshooting issues related to phase behavior and energy transfer in systems. The PV and TS diagrams. PV means pressure volume, TS means temperature entropy, isothermal and isentropic process. In isothermal process, we will take PV diagram. Temperature is constant. TS diagram, pressure is constant. Here we see that dotted lines where adiabatic process. Here is the isobaric process. Diagram we can see the adiabatic process. In TS diagram we can see the isobaric process. Conclusion. The PVT surface, TS and HS diagrams are fundamental tools in thermodynamics. Mastery of these diagrams enables engineers to predict system behavior and optimize performance efficiently. Continuous study and application of these concepts are vital advances in energy efficiency and sustainable practice. Thank you for giving this golden opportunity.